All right. Sorry, everyone, that I can't be there today. Wasn't feeling very well this morning, so stayed home. We are going to skip to 3.5. So we're going to do this in 2 days. But we are going to do graphing after. So graphing is 3.4. We're going to do graphing after this. Because I think it is going to help doing inverse trig functions while we're still fresh on the unit circle. Okay. There is going to be a part of this that we haven't seen yet, but that's okay. It's just kind of the intro part. So a function has an inverse if and only if it is a one-to-one function. This means that it must pass the horizontal line test to have an inverse. Okay, you might remember that from Algebra 2 trig if you took that. But if the domain is restricted to a certain interval, then sine, cosine, tangent functions will have inverse functions. So this is something you haven't seen yet, but you can just kind of trust me for now. This is the graph of sine of x, but technically it just keeps repeating. We call it periodic. It just keeps going and going and going. So if I took a vertical line and just did the vertical line test, this function passes that, right? It's never touching my vertical line more than once, which means the sine function is a function, okay? But the horizontal line test tells us that if we drew a horizontal line and dragged that through our function, this would not pass, which means that the inverse of sine is not a function because it's touching that more than once. So something that we can do, which is what is drawn here for you, is we restrict the function before it starts repeating itself. Because like I said, this would start repeating and going back to certain y values. So what we do is we restrict it between negative pi over 2 and pi over 2. So that's the domain. If we just restrict it between those, then it will pass the horizontal line test, right? If I drag this, it never touches more than once. Okay, so we're going to be restricting all of these functions. So domains between negative pi over 2 and 2. I'm really just going to focus on domain right now. I don't want to waste time on the range because we're not going to need it. So then the arc sine or inverse sine, those mean the same thing. This one would be between negative 1 and 1. Okay. Arc cosine. So the cosine function, again, does the same thing. It just keeps repeating. So same thing, if I did the horizontal line test, it wouldn't pass. So we restrict it so that when we do the horizontal line test, it will pass. So cosine gets restricted domain between 0 and pi. So pi here, 0. Okay, so then the inverse cosine, that's restricted between negative 1 and 1. That's if you reflect it over the line y of x, the inverse. Okay, these are the important ones that we're going to need to come back to. And then tangent, that one's a little weird. That one is actually between two asymptotes, and it just keeps going. So this one, the tangent function is restricted between negative pi over 2 and positive pi over 2. Now this one actually has asymptotes. We'll talk about this when we get into graphing. So that one uses parentheses, not brackets. And then if you do the inverse of that, then the domain's actually negative infinity to infinity. But again, this is the important part we're looking at. Okay, so the big thing here, the summary of the domain restrictions. So sine, when we are talking about the inverse sine, we're going to be looking for an angle that has that sine value. So we're looking at the sine function. We said we're restricting that between negative pi over 2 and pi over 2. So think about on a unit circle. So negative pi over 2 would be swinging down, right? So this is negative pi over 2 and pi over 2. So it's only between these two things, which means it's only in quadrants 1 or 4. So when we're looking for an angle, it can only be in those. So this would be my positive sine, my y values. These would be my negative y values. Okay, cosine can only be restricted between 0 and pi. So thinking about the unit circle, here's 0, here's pi. So cosine can only happen in quadrants 1 or 2. So cosine, you're thinking x value. So here's positive x values, negative x values. Okay, and then tangent, that's actually the same as sine. It's between negative pi over 2 and positive pi over 2. Now I'm putting open circles on this just because they were asymptotes. We use parentheses, but it's otherwise the same as sine. Okay, so positive over positive, that's our positive signs, and then these are negatives. Okay, so we're going to need to draw those and keep those in mind. Okay, so here's the big thing for today, evaluating inverse trig functions. So we're going to use the unit circle. So just for ease here, I'm going to pull up my completed unit circle. Maybe. There we go. Let me erase what's on here. Okay, so first thing, we want to find the exact value. So I'm not telling you radians or degrees. You can give me either answer. I'll put both if it exists. So arc sine. So arc sine is the same as inverse sine. So it doesn't matter if you see that little yellow, -1 or arc sine. But we write this as the sine of what angle equals 1. So you're looking for an angle, degrees or radians, doesn't matter. So we're just thinking, okay, sine is a y value. Okay, now this one, there's really only one option. So I'm looking for an angle on my unit circle that has a y value of 1. So if you take a look at your unit circle, there is only one angle that has a y value of 1. And that's either 90 or pi over 2. Okay, so again, you're just looking for, what is the angle? That's what you're looking for. So the angle would be 90 degrees or pi over 2. That has a y value of 1 because that was sine. Okay, let's do another one. So number 2, so the sine, the inverse sine is -√3/2. So again, this means the sine of what angle is -√3/2. So I don't know what my angle is. Okay, so if you think about that on your unit circle, you want a y value, sine is y, that is -√3/2. So if you're going around your unit circle, y values that are negative, that's below the x-axis. So that could be here. Here's a -√3/2. That's quadrant 3. Or in quadrant 4, -√3/2. But we're not going to put two different angles. Okay, you can only put one answer. So this is where you have to think about your domain restrictions. So we just said it could happen in quadrant 3 or quadrant 4. But for sine, it is restricted between quadrants 1 and 4, right? It looked like this. Okay, so we have to pick the one that is in that domain. So that is the angle either, oops, I'm sorry, I am in the wrong one. The 300 or 5 pi over 3. Now, it's not between 0 and 360. It's between pi over 2 and negative pi over 2, or 90 and -90. So we're only going to use those negative angles. Like if I'm thinking degrees, I could say -90 and +90. So I only want the negatives. Okay, so I'm not going to say 300 degrees for this. I'm going to say -60 degrees. Okay, so this one would be -60 degrees, or in radians, think about your reference angles, that would be -pi over 3. Okay, so for those quadrant 4s, you're only using the negatives because we're not swinging all the way around because that's not part of the domain. Okay, let's do another one. So number 3, sine again. So we want the sine of what angle is -2. Okay, so again, you're looking for a y value that's -2. You could look at your unit circle all day long. You're not going to see it. So sometimes it just does not exist. There is no angle where the y value is -2. Okay, let's do another one. So number 4, so this one is now cosine. So we're looking for an angle that has a cosine of -√2/2. Okay, so again, you could draw your little unit circle. So -√2/2, so that could be in quadrant 2. Or that could be in quadrant 3, right? A negative x value. But you have to think about your domain restrictions. So cosine is in the first 2 quadrants. Okay, so it's either here or here. Now it's a negative. We said this is positive, this is negative. So, and it can't be that third one. So this one has to be in quadrant 2. So we just want to locate what that angle is. Okay, so where it's negative root 2 over 2 cosine, that is 3 pi over 4, or you could say 135 degrees. Either one would be fine. Okay. All right, let's do another one. So the inverse cosine of negative 1. So the cosine of what angle equals negative 1? All right, so this one, again, kind of like that first one. I think it was the first one we did. Yeah, there's only one answer. So why don't you guys look for this and see if you can write the answer. Look for where the x value is negative 1. Okay, hopefully you paused me, tried that. So where the x is negative 1, that's either at 180 degrees or pi radians, either one. That's right here. All right, I'm going to skip to number 7. This one, tan is always a little trickier. So here, inverse tan of root 3 over 3. So I'm looking for an angle that has a tangent of root 3 over 3. Now, tangent, remember, isn't just x or just y. It's y over x. So we're actually kind of thinking about if we divided y over x, what would give us an answer of root 3 over 3. You might remember this from Algebra 2 trig. If you remember your patterns, that's great. But you might just have to plug something in and try it. So just remember your domain restrictions first. Erase all these. So tangent can only happen, it's just like sine, in quadrants 1 or 4. Okay, so it's between 90 and negative 90, or pi over 2 and negative pi over 2. Okay, so think about which one would give you a positive answer if you divide. So remember, this is positive, positive, this is positive, negative. So hopefully you're recognizing that it has to be quadrant 1, right? Because a positive over positive will give you a positive answer. So it's something in quadrant 1 that when you divide it will give you root 3 over 3. Okay, so it's obviously not going to be pi over 4, because if I divide these two things, that'll give me 1. So we have to decide, is it pi over 6 or pi over 3? So I would just pick something and try it. So maybe if I just start with the first one, y over x. So let me do, oh, I don't have a lot of room here. Let me do 1/2 divided by root 3 over 2. I'm doing y over x. So that's 1/2 times the reciprocal, 2 over root 3. 2's cancel, I get 1 over root 3. Rationalize that. Yikes, I'm running out of room. Let me go up here. So we get root 3 over square root of 9, which is 3. Okay, so that's actually what we wanted. So that means that this angle that I picked, that 30 degrees or pi over 6, that is my answer. Okay, so just kind of test it out, try it. And then once you do a few of those, you might remember it. Okay, I don't want to make this video super long, so I'm going to skip to the last part here using your calculator. So let me get rid of my unit circle, and let me open up my calculator, and hopefully this shows up okay. All right, so on your calculator, you can also evaluate trig functions, just not using your unit circle. So the directions do tell us here, make sure your calculator's in radian mode. So click on mode, arrow down, mine is in radians, so that's good. If yours is in degrees, change it, make sure it's radians, otherwise you're gonna get the wrong answer. We're just gonna type this in exactly as it looks. So inverse sine, you hit the second button, and then sine, and then negative 0.74, enter. All right, this says to round it to 3 decimal places. So this is negative 0.833. Okay, that's in radians because our calculator is in radian mode. You could convert this, if I asked you to, you could convert this to degrees using your conversions, right? So if I want to convert this to degrees, that means that the pi would be on bottom. So I could multiply by 180 over pi and just get a decimal degree answer. So I'm going to try that. So 180 divided by pi. And you would get about negative 47 point, let's keep going 3 decimal places, 731. And that would be in degrees. Okay. Let's do another one of those. So inverse cosine. So again, I'm just going to type this right in my calculator. So inverse cosine of 1.5. Okay, so this type of calculator says non-real answer. Yours might come up and say error or whatever. So that means that just like the ones we did before, sometimes it might be does not exist. Okay, all right, like I said, I don't want to make this video super long. So there's a couple more you could try. But yeah, so be able to evaluate those trig functions, finding your angles, the inverse trig functions. And also on your calculator. Okay, there's a lesson check for today. Please try that. Come in tomorrow with questions on this. We'll answer those first, and then we're going to go into the second part, which is the reciprocal functions. Okay, email me if you need anything, but have a great day, guys. Thanks.